We're going back to hypothesis testing now under proportions. Now, when we go back to proportions, we go back to your z-score. If you remember back when we did your confidence interval with proportions, a proportion is made by x over n for your sample. How many said yes over how many you sampled? And they're binomial numbers. They're whole numbers. You can't have a partial response on this. So we had a binomial situation. So to make sure that your binomial situation approximated a normal curve, we ran these two tests. We did these two tests. N times p greater than or equal to 5, n times q greater than or equal to 5. We took the smaller of the p or q. If that passed, then we were good to go with that. If the smaller one didn't pass, we couldn't do anything. There's nothing else you can do with this because it doesn't approximate a normal curve. Again, your binomials, it usually told you like you sampled, say, 125 people and asked them if they would take a statistics course in college, and 32 of them said yes. To find your proportion, we did x over n. And we set it into a decimal. So that found our proportion for our sample. We're going to do the same thing when we test a claim. We're going to get a claim about the population. We're going to sample a certain amount of people who respond x equals, and we're going to build our p hat from that and test from your p hat. Okay? Your test statistic for your z-score for a proportion, it's a little bit different than your other z-score, but if you notice, the sample mean came first, your sample proportion comes first. This is p hat from your sample, which was x over n. This is p from your population. So it's kind of like the same setup, sample minus population. It just so happens that both are proportions. Divided by the p and the q, this comes from your proportion. And you know how we divide by your square root of n? Well, this time n is underneath the square root. This is your sample size. You sampled 125 people. Okay. There is a calculator step for this, but we're going to do it out the long way first, and then I'll show you on the calculator. Alright, so that's like the only major difference. Since we're back to a z-score, we're back to table 4. Your critical cutoff values will now come back from inverse norm, when you inverse norm this. And the same thing applies with the two-tail. You'll divide it by 2. What do you mean? Probably like next week. Probably today, Tuesday. Probably the beginning of next week. Okay. Basically, it has the same setup. The first thing, instead of assuring that this is a random sample and that n is greater than or equal to 30, instead we do the test. N times p greater than or equal to 5, n times q greater than or equal to 5. We state your claim, your level of significance, we sketch your reject regions, we look up table 4, we find your cutoff value based on your level of significance, we label all that, we use your test statistic instead of the z, x minus the mean, we use this one instead, we make a decision, and then we interpret the decision. This is quick and it's easy, because there's not a lot to this. So let's try one. This is on page 389. A researcher claims that less than 40% of U.S. cell phone owners use their phone for most of their online browsing. In a random sample of 100 adults, this is your sample part. This is your population part. This is your sample part. We're going to do a proportion of P, because it's giving us a percent. Percent is like a decimal. Proportion. P, proportion, percent. So, P, population, less than 0.40. This is our claim. Is this an HO or an HA? HA. What's the HO? Okay. Now, here comes our sample. In a sample of 100 adults, 31% of them said they use their phone for online browsing. So out of the 100 people that were asked, 31 of them said they use their phone. So our p hat is 31%. Now how did I know 31 of them said yes? Out of 100, so 0.31 times 100, I'm without my decimals, so I know that my x was 31, because my p hat is 31 over 100, right? I just worked it backwards. Sometimes they give you the x, sometimes they give you the sample proportion. Okay, at a level of significance of 0.01, is there enough information to support the claim? Support means we should use the word HA as our claim. Is HA our claim?
Yes.
Okay, what tail do we have? A left tail. So we're going to label this reject H0, and we're going to label this fail to reject H0. Now we have to find your critical value. We're back to your z-score. So if this area is this piece right here, we do inverse norm, and we just put in the 0.01, and we find your z-score. If this was a right tail test, we can still put in 0.01. Then if it was negative, we would know it was the same and positive. Good so far? So we know where to cut this off. We know an area and an associated z-score. So, so now we're going to test using your test statistic, which this was supposed to be Z. Z equals p hat, that's your sample, minus your population over the square root of p times q divided by n. So we know p is 0.40. What's q? Good. Q is 0.6. 0.60. So now, just fill them in. Your p hat was 0.31 minus 0.40 over the square root of 0.4 times 0.6 divided by 100. If you put this in your calculator, make sure the numerator has parentheses, or use your fraction bar key. Alpha y equals will set up your fraction bar. Don't go all the way through this and make a mistake by putting it in your calculator. So this z-score comes out to be what? Q. P, Q.
Like a 1.837.
So negative 1.84. Z-scores will be 2 decimals, right? And it doesn't really matter. It's you're in the ballpark. You're fine with whatever you round to. So we follow our graph and we say if this is the 0, the negative 1.84 falls about here. What is my decision?
Fail to reject H.
Fail to reject HO. So if we fail to reject the HO, oops, this is my HO. Which one is that? If we fail to reject HO, could we possibly support the claim? No, because we're going to have to take the HO. So we follow our chart and we say there's not enough evidence to support the claim that less than 40% of all cell phone users use their phone for most of their online browsing at a level of significance of 0.01. Now, we've got your area. Here's your area, 0.01. Here's your z-score. This guy was cut off here. We found this z-score. And now let's find the area associated with this guy. Find me your p-val without your calc. How do I find your p-val? Table 4. Look it up in table 4. Look up negative 1.84. So if I ask you to test for p-val, you just pull this up, your table 4, we're back to your z-score. And what's your p-val? Okay? Okay. So we know our areas and we know our z-scores. So if I'm going to test my p-val from a level of significance, make sure you test it in this order. Fill this, and this is greater, and I'm still failed to reject H0. Good? Now, for those of you that like the calculator, the step on your calculator is under your stat. There's your z-test we did. There's your t-test we did. It's number 5, 1 proportion z-test. We're doing a z-test, but we only have 1 proportion to examine. That was the proportion just of the cell phone users. So when you hit this, that's your population proportion. That's your 0.4. It needs the x and the n. So if they gave us 31%, we have to take 31% times n. And in this case, our x was 31. Our n was 100. Again, you're going to follow your tail. Your tail is a less than, and we're going to calculate. When it comes back, it gives you your p-hat. Make sure your p-hat matches yours. It gives you your z-score, and it gives you your p-val. There's your p-val right there.
Oh, you have to make a last
At the test. So go to stat, test, come here, and type those all in. You have to put an x value in. Remember, if I had 97 people in my sample, and I had to take 31%, if I get a decimal, you cannot put a decimal in here because it's a binomial thing. You can't have a perfect person. The inverse norm, we're back to inverse norm because we're back to a z-score. The only time we use a t is when we don't know a standard deviation for the population. But a p, a proportion, doesn't use a standard deviation. That's back to our binomial p and q. We should have tested, by the way, we should have tested n times p is greater than 5, n times q is greater than 5. It had to be, or we wouldn't be able to use this. Okay, so you can use your calculator, but you have to work your way backwards a little bit. All right, I want everybody to try it once, but I want you to do this with your formula first. If you want to then put it in your calc, that's fine. But I want the statements, I want the sketch, I want to see the formula out there. I'll give you that formula. You don't have to memorize that. The only one I make you memorize is just your standard z-score.
Which one is it?
Try it 1 on the bottom of 389. Same way we just did the last one. Give me your plane, your HO, HA, follow your tail. Use your sketch and then label it for your reject regions. If you want at the end to throw in your p-val, that's fine too. The more information you find out about it, the better off you are. Okay, plane. Brianna, give me the plane. It's an HA, okay, and good. P is greater than 0.30. 30%, put it into a decimal. Okay, P is greater than 0.30. What's the HO? Good. Okay. Person, what tail test do we have? A one tail? What? A right tail. Okay. So this says reject H0. This says fail to reject H0. Cutoff value. Ricky, what's my cutoff value? Okay, so what's my level of significance? So that means this area has to be 0.05. So since we're back to our z-score, do an inverse norm. Go on your calc and do inverse norm, second bears, inverse norm, and do a 0.05 in your area. So if I'm in the negative, look up here a sec, but I'm on the right-hand side, so 1.645. Good. That's my cutoff value. That's where I'm going to say, use this to find my test statistics. So my test statistics says, here's my sample information. N is 150, P hat is 0.38, and I'm at a level of significance of 0.05. So I know my P hat minus my P over E is 0.3, what's Q? 0.7 divided by my N. So make sure there's parentheses around that. Tell me what you get for your z-score. There's no x. Well, we don't need an x for this, but if you're going to use an x, take 38% of 150. Okay. So 2.14, since it's a z-score. Good. Now, we're going to look in here, and it falls right in here. So, Rachel, what's my decision? Good. My decision is reject HO. And Bridget, what's my interpretation?
There is enough evidence to support the claim that more than 30% of U.S. smartphone owners use their phone touch phones.
Good. Thank you. So there is enough evidence. If we're rejecting HO, we have to go with the claim. So there is enough evidence to support the claim that more than 30% of U.S. smartphone owners use their phone while watching TV. Good. Now, Angela asked for an X. Your calculator needs an X and an N. So you're going to just do this. 38% of 150. So your X is 57. You're going to put that in your calculator if you're going to use your calculator. You can bypass a lot of this. We'll check your p-val in a minute, but we can check our p-val right off of this. Your proportion for your population is 0.3. Your X would be 57 over your N. Remember, you can't put any decimals in there. My tail is greater than, and I'm going to calculate. There's my z-score. Here's my p-val. And check to see, was my p-hat 0.38? Yes. My p-val is 0.0163. I'm going to test it against my 0.0500, less than or equal to, reject is 0. Or I could look up in my z-score, 2.14, but notice it's very large, so I either subtract it from 1, or therefore look up the negative 2.14. Are you guys getting comfortable when we use it on the positive side versus the negative side? Yeah. Okay. Okay. Questions on this? We walked it all the way through. Not a lot of difference. Just in your P, your Z statistic test, the rest is working just about the same. Claims, cutoff, vowels. Okay.
Can you talk me through this thing? Because it's not coming from my this part. My question. This one is there.
But it's going to be around the top.
So you like that's my friend at school. I was thinking mom was okay. So
All right. Tomorrow, guys,